Hello, everybody. Sorry I can't be here to start you out on Taylor polynomials. Um, Really an interesting subject, I think, but difficult at times. But I wanted to give you a worked example for problem number 5 and then sort of some motivation for what we're doing in this whole section. So before I do problem number 5, I want to say we've been working with series, and so Taylor polynomials are really just a series that give us a new representation for a function. And what I mean by that is if I have a function like f of x is equal to the sine of x, well, that is not a polynomial. But using a Taylor series, I could represent it as a polynomial function. And how exact I want it to be will depend on how far this series goes out. So the way to read this is a Taylor polynomial of degree n is equal to the summation of the terms the nth derivative x minus c, where c is where we're going to center the function, to the nth power over n factorial. So you see the n's agree in all of these, which makes it easier. We're going to come back to this, and now I want to work on problem number 5. And so the idea here is for our polynomial right now, we're really just going to do a linearization. So I'm going to say linearization because they ask us to do P1, which is that. And so the formula for this is going to be f of c plus f prime of c times x minus c. And this is nothing new. You may not remember it, but it's our formula for linearization. Here's where we're starting. Here's how far we're going. Sometimes we write that as delta x. And here's the route we're taking, the slope we're moving from the initial point there to our new x. And for this particular problem, they give us that f of x is equal to 8 over the square root of x. Well, I'm going to write it this way, x to the 8 times x to the minus 1/2. It will be easier for taking my derivative. And they tell us that c is equal to 4, I believe. C is equal to 4. So what I still need is this. I need to know what f prime is equal to. So f prime of x. Well, if I take the derivative, it looks like I end up getting negative 4 over x to the 3/2. So you may want to check my work on that. If I take the derivative, I get x to the negative 3/2 multiplied by negative 1/2 gives me negative 4. And now I'm going to find out what these are equal to at c equals 4. So f of c is going to be equal to 8 over the square root of 4, and that gives me 4. F prime of c is going to be equal to negative 4 over x to the 3/2. I'll write it this way. And that should be equal to negative 1/2. Again, check my math on that, but I believe that's right. And now I've really done my work. P1, and I'm going to call it P1 here, just to make the point we are moving on to something new, is equal to f of x plus f prime of x, x minus c, and in this case f prime, this should be f of c and f prime of c. And that's going to be the first power. Well, f of c is equal to 4 minus f prime c 1/2 x minus c. And there's my answer. Okay, c I could put in here. It's x equals 4. And there's my polynomial. So I took this odd-looking function that isn't too bad, but it isn't a polynomial, and I rewrote it as a polynomial function. Well, what I should say is I've approximated it because I've only gone out 2 terms. What the Taylor series tells me, if I want a more exact answer, I'm going to go out more terms. So we could imagine what would be the next term. Well, the next term would be f double prime c x minus c squared. And now I'm going to put it over 2 factorial, which seems like I'm throwing something new in here, but I'm really not, because if you think back to my formula, it's equal to f of c, well, that's really my zeroth derivative because it's the function itself, times x minus c to the zeroth. Well, we haven't bothered writing that because that's just 1 over 1 factorial. The second term is f first derivative c x minus c. We haven't bothered writing the 1 because that's what it is, over 1 factorial. We haven't bothered writing this because it's just 1. But now if I want to march ahead to the next term, and we're not doing that for most of the homework problems, the next term would just be f double prime c x minus c. Well, I could figure out what f double prime c is. This is just going to be x minus 4. I'm on the second derivative, so the second degree for that over 2 factorial. There's where the new things start coming in. And I could, at this point, it's like going down a slippery hill on a sled or something, because I could just continue coming up with closer and closer approximations by following the formula I had there above. So notice I went ahead, and now I have not P1, but P3 because I went out to the third order. Okay, so once again, we're kind of getting started on Taylor series and Maclaurin series, where we're going to be approximating polynomials using functions. All I really wanted to do was work out problem number 5 for you, and you could see the solution here. You know, in the book they may have reorganized this into 4 minus 1/2 x plus 2 or something like that, but I prefer it in this form anyway, I think, because it reminds me I'm working with an approximation using linearization. Okay, well, I hope that helps you a little bit. The other problems are very similar to this. What are you going to do? Here's what you're going to do if I've totally confused you, to find the first degree polynomial, and that's going to be for the problems 5 through 7. You're just going to say, okay, they're going to give us a c. Well, they're going to give us a c equal to something. Why am I writing that? And we're going to say, okay, let's take f of c plus f prime of c x minus c, and that's my approximation. Remember that really there are these other terms here that would fit in if I wanted to be more exact and show every step in the Taylor series. Best of luck to you. I'll see you. If you have any problems, I'll be around Tuesday morning before school, and if anybody wants to work during the activity period on Tuesday, I don't have anything. No guitar club or anything, so please stop by. I think you'll find this set of problems not too bad, but try to develop a deep understanding because we're digging further with Taylor series, and it's not